Let's get something straight first. Time travel isn't weird. Your thinking about time is what's weird. Most discussions about time travel are childish. You go back, you kill your grandfather, you disappear. That's not a paradox. That's a failure to define the rules. Here's the paradox you've probably never heard of. If time travel is possible, then ignorance becomes impossible. Think carefully. Suppose you travel back 10 years to prevent a mistake. If you succeed, the mistake never happened. If the mistake never happened, you never had a reason to go back. People call this a loop. That's wrong. It's not a loop. It's a logical self-erasure. Now, here's where it gets uncomfortable. We assume time is something that records events, but time doesn't record anything. Time enforces consistency. Reality does not allow contradictions, not because they're dramatic, but because they're meaningless. So if you went back and changed something, one of three things must be true. You didn't actually change anything. You created a new separate history, or the concept of changing the past is nonsense. Let's destroy the first one. If nothing changed, then free will is cosmetic. You're acting, but the outcome is already locked. That's not freedom, that's choreography. The second option sounds better, multiple timelines. But now you've made the universe do accounting. Every decision splits reality? Then the universe isn't elegant. It's wasteful. Nature doesn't multiply paperwork unless forced, which leaves the third option. Maybe the paradox exists because the question is malformed. We ask, can I change the past? But that assumes the past is a thing you can edit. It isn't. The past is not a place. It's a logical consequence of the present. You don't go back in time the way you walk into another room. You would have to violate causality, the very rule that allows events to exist in order. And here's the punchline most people miss. If time travel were truly possible, knowledge would travel faster than causes. Information would arrive before reasons, effects would precede explanations. At that point, science collapses. Prediction replaces understanding, and understanding is the whole game. So maybe the universe solved the problem already, not by banning time travel, but by making self-consistent histories the only ones that can exist. No contradictions, no rewrites, no dramatic rescues. Just one brutal rule. If an event happened, it happened because it could happen, without breaking logic. And that's the paradox you've never heard of. Time travel doesn't fail because it's impossible. It fails because reality refuses to explain nonsense. If this made you uncomfortable, good. That means you were thinking time travel isn't paradoxical because of machines. It's paradoxical because of logic. That single sentence already eliminates 90% of the nonsense people talk about. Shiny devices, spinning portals, flashing lights. None of that matters. You can imagine any machine you want. The real problem starts the moment you ask a simple question: what happens when cause and effect stop agreeing with each other? People love to blame technology for the paradoxes. They think the universe breaks because a machine is too powerful. That's comforting because machines feel optional. Logic doesn't. Logic is not a feature of reality, it is reality. When logic collapses, nothing meaningful is left to talk about. Take the classic idea you go back in time to change something. Already, that sentence is infected. Change compared to what? If the past can be changed, then it wasn't the past. It was just a draft. And if the past was only a draft, then the present has no authority. Everything becomes provisional. Reality turns into a rough sketch with no final version. Now slow down and be precise, because precision is where weak ideas die. If you travel back to prevent a disaster, and you succeed, then the disaster never occurred. If it never occurred, then the knowledge that motivated you to travel back never existed. If that knowledge never existed, then the trip never happened. That's not drama. That's contradiction. A statement that deletes the conditions required for its own existence is not mysterious. It's meaningless. Most people try to escape this by saying it just creates another timeline. That sounds smart until you examine it. What justifies the split? What physical rule says reality must duplicate itself to protect your feelings about free will? If every altered event spawns a new universe, then the universe is doing infinite work to preserve human storytelling. Nature does not care about your narrative satisfaction. When a theory becomes bloated just to survive criticism, it's already on life support. Others say, you were always meant to go back, everything is fixed. That's cleaner, but now you've paid a different price. Choice becomes decoration. You can deliberate, struggle, panic. The outcome remains unchanged. You're not an agent, you're a performer reciting lines you didn't write. That may be logically consistent, but it empties responsibility of meaning. If nothing could have happened differently, then explanation replaces accountability, and explanation alone is not enough to live by. Here's the deeper problem most people never notice. Time travel doesn't just threaten events, it threatens knowledge. Knowledge depends on order. You learn something because something else happened first. But if information can travel backward without its causes, then knowledge detaches from reality. You could receive answers before questions exist. You could act correctly without understanding why. At that point, science stops being a method and turns into a coincidence generator. Predictions might still work, but understanding evaporates. And without understanding, you're not doing science, you're doing fortune-telling with equation. People assume paradoxes are exotic edge cases. They're not. They are alarms. A paradox is reality telling you your definitions are broken. When logic produces a contradiction, it's not asking you to be impressed, it's telling you to stop. The mistake is imagining time as a container, like a hallway you can walk back into. Time is not a place, it's a constraint. It's the rule that says events must be ordered in a way that makes explanations possible. Remove that rule, and event stops meaning anything at all. You don't ask whether you can travel outside logic any more than you ask whether you can draw a square circle. The words fit together grammatically, but they don't point to anything real. The universe doesn't forbid nonsense, it ignores it. So when people ask, is time travel possible? They're usually asking the wrong question. The better question is, what kinds of histories are allowed to exist without contradiction? And the answer seems brutally simple. Only those where every event fits consistently with every other event. No edits, no retroactive justifications, no exceptions made for clever ideas. That doesn't mean time travel is impossible in every mathematical sense. It means that if something resembling it exists, it will not behave the way stories demand. It won't let you fix your regrets, save the day, or rewrite mistakes. It won't give you power over history. It will preserve consistency at all costs, including your expectations. And that's the uncomfortable conclusion people resist. The universe doesn't care what you want to change. It only cares whether your story makes sense. If it doesn't, reality doesn't argue. It simply refuses to participate. Most people misunderstand causality. They treat time like a road instead of a rule. That single mistake quietly ruins almost every conversation about time, choice, and reality. A road is something you move along. A rule is something that constrains what movement even means. Confuse the two, and you start asking questions that sound deep but collapse the moment you apply discipline. When people imagine time as a road, they picture themselves as travelers, forward, backward, detours, exits. It feels intuitive because we evolved to think spatially, but intuition is not evidence. A road exists independently of the traveler. Time does not. Time is not something events happen in. It is the condition that allows events to be ordered at all. Remove that condition and before and after lose their meaning. Causality is not a habit of the universe. It's a requirement. Without it, explanation dies. If an effect can occur without a cause or before its cause, then why becomes a decorative word. You can still describe what happened, but you can't understand it. And a universe that allows description without explanation is not mysterious. It's useless. The road metaphor fails because roads allow revisiting. You can turn around, retrace steps, take alternate paths. Rules don't allow that. You don't visit the rules of arithmetic. You obey them or your answers stop meaning anything. Time works the same way. You don't walk through it. You conform to it. This is why people get confused about free will. They imagine choice as standing at a fork in the road, left or right. But causality doesn't present forks. It presents consequences. Your decision is not floating above the past. It is shaped by it. Your thoughts, values, fears, and impulses did not appear from nowhere. They are the result of prior conditions. That doesn't make choice an illusion. It makes it a process. A process still counts, even if it has a history. Treat time like a road, and you start believing in do-overs. Treat it like a rule, and you realize something harsher. Once an event exists, it constrains everything that follows, not morally, logically. The universe doesn't punish you for mistakes. It incorporates them. People resist this because it feels cold. They want time to be forgiving, but forgiveness is a human concept. Physics deals in consistency. Once something has happened, it becomes part of the structure future events must fit into. You can't erase it any more than you can erase a solved equation without breaking the logic that led to it. This misunderstanding also infects how people think about the future. They imagine it as an open stretch of road, empty and waiting. But the future is not empty. It is tightly constrained by the present, not fixed in detail, but bounded in possibility. Just as chess allows many games but forbids illegal moves, reality allows many futures but rejects contradictions. Freedom exists inside rules, not outside them. When people say causality is broken at small scales or extreme conditions, they usually mean their expectations are broken. The universe did not stop obeying rules. It revealed rules that don't resemble everyday experience. That's not a failure of causality, it's a failure of imagination. The road metaphor also leads to a dangerous comfort, the belief that if something goes wrong, you can always go back. But causality doesn't work that way. Consequences propagate forward not because the universe is cruel, but because coherence demands it. If effects didn't follow causes, nothing could be learned. Memory itself would be unreliable. Learning requires order. Order requires rules. This is why the past feels heavy, not emotionally, structurally. The past is not heavy because it hurts. It's heavy because it's already integrated into the framework of what exists. You don't carry it. You are built on top of it. Every moment rests on an accumulation of earlier moments, whether you acknowledge them or not. Seeing time as a rule doesn't eliminate wonder. It sharpens it. The fact that the universe permits stable patterns, reliable explanations, and cumulative knowledge is not obvious. It is an achievement of consistency, and consistency is fragile. Break it, and meaning collapses with it. So when someone asks whether time can be bent, reversed, or escaped, the real question is simpler. Can the rules that allow explanation survive that change? If not, the idea isn't radical, it's incoherent. Time is not a road you travel. It is the rule that makes travel intelligible at all. The real paradox isn't can you change the past, it's what does change even mean? That question sounds harmless until you realize almost no one ever defines it. People argue passionately about altering history without agreeing on what alteration requires. They assume change is obvious, like repainting a wall or editing a document. But the past is not an object sitting around waiting for revision. It is a logical structure, and structures don't respond to wishful thinking. To change something, there must be a reference state. Change implies comparison before and after, but the past already is the before. There is no external vantage point from which you can observe two versions of the same past and declare one altered. If you claim a past event has changed, you must answer a brutal question: changed relative to what and observed by whom? People imagine time like a recording that can be paused, rewound, and overwritten. But recordings exist in time. The past does not. Once an event occurs, it becomes part of the explanation of everything that follows. You can't revise an explanation without revising the thing it explains. That's not editing. That's erasing coherence. Suppose you go back and prevent a mistake. If the mistake is prevented, then the history in which it occurred never existed. If it never existed, then the description prevented has no target. You didn't change anything, you replaced the entire context in which the word mistake made sense. Language breaks first. Logic follows. This is why people retreat to the idea of multiple timelines. They think it solved the problem by allowing two incompatible histories to coexist. But coexist where? If both histories exist, then nothing was changed. Something new was created. That's not time travel, it's universe duplication. The original past remains untouched. The word change is smuggled in, doing work it never earned. Others argue the past can be changed but must remain self-consistent. That sounds precise until you notice it quietly eliminates change altogether. If everything remains consistent, then whatever you did in the past was already part of it. You didn't alter history, you fulfilled it. The language of change survives, but the substance disappears. The discomfort comes from realizing that change is a present tense concept. Change happens to things that are still happening. The past, by definition, is not happening. It is settled, not emotionally settled, logically settled. Treating it as malleable confuses process with record. This confusion leaks into everyday thinking. People say they want to change the past when they really mean they want the consequences to stop mattering. They want relief, not revision. But consequences don't listen to desire. They propagate because that's what consistency demands. To understand why the paradox persists, notice how casually we treat time as a backdrop. We imagine ourselves stepping outside it, manipulating it like a tool. But any act of manipulation would itself require time to occur. You can't step outside the condition that allows stepping. The moment you try, your description eats itself. If change were possible in the past, then truth would become unstable. Facts would require timestamps, not just for when they occurred, but for which version of reality you're referring to. Knowledge would lose its footing. Science would become archival guesswork. Memory would stop being evidence. The universe seems allergic to that kind of instability, not morally, structurally. It permits uncertainty, probability, and surprise, but it does not permit contradictions that dissolve meaning. When an idea implies something both happened and did not happen, in the same explanatory frame, the universe doesn't get dramatic. The idea simply fails to describe anything. So the paradox isn't about machines or loops or daring rescues. It's about language outrunning clarity. We use the word change because it works so well in ordinary life, then we drag it into a domain where it no longer applies. When the contradictions appear, we blame reality instead of our definitions. Once you strip the romance away, a quieter picture emerges. The past is not a thing to be edited. It is the fixed set of conditions that make the present intelligible. You don't change it, you are constrained by it. And within those constraints, you act, choose, and create consequences that will one day become just as fixed, that may feel limiting. It's actually what makes meaning possible. A world where the past could be changed wouldn't be flexible, it would be unintelligible. Nature doesn't care about intuition, it only respects consistency. That statement sounds harsh because intuition feels personal. We trust it. We grow up using it. It helps us survive. But survival is not the same as truth. Intuition is a local tool, shaped by evolution to handle falling objects, social signals, and immediate danger. Nature, on the other hand, operates without concern for what feels reasonable to the human mind. The mistake people keep making is assuming that what feels obvious must be fundamental. It isn't. Intuition is an afterthought, a side effect of biological convenience. Nature existed long before human expectations and will continue long after them. It does not adjust its rules to make sense to us. It does not slow down to explain itself. It simply remains internally consistent. Consistency is the quiet backbone of reality. Without it, nothing holds together. If the same conditions could produce different outcomes without reason, then explanation would be impossible. You could describe events, but you could never understand them. Science would collapse into storytelling, and prediction would be reduced to guessing. Consistency is not elegance, it is necessity. This is why reality so often offends common sense. Common sense evolved for mid-sized objects moving at moderate speeds, not for particles that behave like probabilities or space-time that bends under mass. When intuition clashes with evidence, intuition loses. Not because it's stupid, but because it was never designed for this scale of truth. People often say, that can't be right, it doesn't make sense. What they really mean is, it doesn't match my internal model. Nature is under no obligation to respect that model. The only thing it must respect is that its rules do not contradict themselves. As long as they don't, the universe is satisfied. This is why paradoxes matter. A paradox is not a mystery to admire, it's a warning label. It tells you your assumptions are inconsistent. The universe does not resolve paradoxes for you. It exposes them and waits. If you insist on keeping contradictory ideas, the failure will belong to your explanation, not to reality. Consider how often intuition misleads. It says time flows at the same rate everywhere. It doesn't. It says objects are solid and separate. They aren't. It says cause must always come before effect in the way we imagine it. Even that turns out to be more subtle than expected. Each time intuition fails, consistency remains intact. The rules hold, even when our understanding breaks. People romanticize the idea that reality should be understandable. But understandability is a luxury, not a right. The universe is not a classroom designed around human cognition. It is a system that happens to allow observers like us to exist. That allowance does not include comforting explanation. This is also why technological metaphors fall apart. We compare the universe to computer simulations or machines because those are things we built. But those metaphors borrow their coherence from nature's consistency in the first place. We didn't invent logic, we discovered it. And logic doesn't bend to preference. When intuition and consistency collide, the responsible move is not to defend intuition harder, it's to interrogate it. Ask why it feels obvious. Ask what assumptions are hiding underneath. Most intuitive beliefs are just habits we've never been forced to justify. Consistency doesn't mean rigidity. Nature allows uncertainty, randomness, and probability, but even those obey rules. Randomness is not chaos, it's structured unpredictability. Even chance has boundaries. Even uncertainty has mathematics. That's the point most people miss. The moment you accept that consistency outranks intuition, your thinking changes. You stop asking whether something feels right and start asking whether it holds together. You stop trusting first impressions and start demanding internal coherence. Confusion becomes a signal, not a failure. This attitude is uncomfortable because it strips away the illusion that the universe owes us clarity. It doesn't. Clarity is something we earn by aligning our models with what is consistent, not with what is comforting. Nature does not negotiate with human instinct. It does not reward imagination unless it respects structure. It does not care what you expect, only whether your ideas contradict themselves. That indifference is not cruel. It's the reason anything works at all. If a theory allows contradiction, reality will quietly refuse to cooperate. It won't explode, it won't announce an error, and it won't argue with you. It will simply stop making sense under that theory, and the failure will be yours to notice. That quiet refusal is how reality enforces discipline. Contradiction is not a dramatic problem, it's a fatal one. The moment a theory permits two mutually exclusive outcomes under the same conditions, it loses the right to explain anything. Explanation depends on exclusion. To explain why something happened is to rule out why it didn't. When a framework allows both, it explains neither. People often mistake contradiction for complexity. They say it's subtle or it's beyond our understanding. That's an excuse. Complexity still obeys rules. Contradiction does not. A complex system can be hard to predict, but it remains internally consistent. A contradictory system cannot even be wrong in a useful way. Reality has no mechanism for handling inconsistency. It doesn't average contradictions. It doesn't compromise between them. It simply behaves in one way every time the same conditions occur. If your theory predicts otherwise, reality doesn't adapt. Your theory dissolves. This is why failed ideas often linger in language long after they've failed in practice. People keep using the words because the contradictions are not obvious at first glance. The theory sounds plausible. It feels flexible, but flexibility that allows anything to happen explains nothing. When everything is allowed, nothing is constrained, and without constraint, there is no understanding. Consider what a contradiction actually does. It breaks implication. If A can lead to B and not B under identical circumstances, then observing A tells you nothing. Knowledge collapses into noise. Memory loses meaning. Prediction becomes superstition. And yet, people cling to contradictory ideas because they are emotionally convenient. They let you keep incompatible beliefs without choosing. They protect intuition at the cost of coherence. But nature doesn't care about that comfort. It only responds to what is consistent. This is why experiments are ruthless. They don't care how elegant your theory sounds. They don't care how long you worked on it. They ask one question: does reality behave the way you say it does? If not, the conversation ends. Not loudly, definitively. When a theory fails, reality doesn't fail with it. The universe continues behaving exactly as it always has. Only your desk. Ription collapses. This asymmetry is important. It tells you where authority lies. Reality is the judge. Theory is the applicant. People sometimes think contradictions can be isolated, patched over, or postponed. They can't. A single contradiction infects the entire structure. Once you allow one, you've abandoned the principle that makes explanation possible. From that point on, every conclusion is optional. This is why just so explanations are dangerous. They are stories designed to fit outcomes after the fact. They don't predict, they excuse. And because they can be adjusted to explain anything, they are immune to correction. That immunity is not strength, it's irrelevance. Reality resists being cornered by bad ideas. It doesn't protest, it just stops lining up. Measurements drift, predictions fail, patterns vanish, not because the universe changed, but because your map no longer corresponds to the territory. The refusal is quiet because it has to be. If reality reacted dramatically to every wrong idea, nothing would be stable. Instead, it remains indifferent. It allows you to be wrong as long as you like. It simply won't reward you with understanding. This is also why consistency feels so powerful when you encounter it. A consistent theory doesn't need decoration. It doesn't need excuses. It works across cases, across scales, across time. Its strength is not in its ambition, but in its restraint. Contradiction is a signal to stop, not to improvise. When you encounter one, the correct response is not to push harder, but to step back and ask what assumptions smuggled it in. Somewhere a definition was sloppy, a concept was overloaded, or a metaphor was mistaken for a mechanism. Reality will not bend to save a broken idea. It will not explain itself twice to accommodate confusion. It will simply continue being what it is. And if your theory cannot keep up, reality won't argue. It will quietly refuse to cooperate. You think you know what you're asking when you ask, why do magnets repel? H, you don't. And until you understand why your question is broken, you're going to be frustrated by every answer anyone gives you, including mine. Let me show you the problem. Pick up two magnets, north pole to north pole. Feel that push, that invisible resistance in empty air. You want to know why? You want me to say magnets repel for the same reason that H and then fill in the blank with something. Familiar rubber band springs too, hands pushing against each other, something you already understand. Here's the thing. There is no familiar thing, H, and I'm not being difficult. I'm not hiding behind complexity. I'm telling you the truth that most people don't want to hear. Magnetic forces are fundamental. They're rock bottom. There's nothing underneath them to compare them to. You're asking me to explain electromagnetism by comparing it to something simpler, but there isn't anything simpler. That's like asking me. To explain arithmetic by using something more basic than numbers can't be done. H. Now you're thinking, wait, I've heard. Explanations. Magnetic fields, electrons, spinning. Those sound like deeper. Explanations, no, they're descriptions. Very precise, very accurate descriptions. They tell you how the force behaves, not why it exists in the first place. And you need to understand the difference between those two things or this entire. Conversation is pointless. Let me ask you something. Push your hand down on your desk right now. Go ahead, push hard. Why doesn't your hand go through? You'll probably say because the desk is solid. Wrong. Not wrong because the desk isn't solid. It is, but wrong because that's not an explanation. That's just another label for the thing. You're trying to understand. Try again. Why doesn't your hand pass through? Because the atoms are packed together. Better. Keep going. Why don't the atoms in your hand pass through the atoms in? The desk? Because atoms are solid too. No. Stop. Think about this. Atoms are not solid. An atom, it's mostly empty. Space, if you scaled an atom up to the size of a football stadium, the nucleus would be a P at the center. The electrons would be tiny dots way out near the seats. Everything in between is empty. Your hand is essentially all empty space. The desk is essentially all empty space. So why don't they pass through each other? You're starting to get uncomfortable now. Good, you should be. The answer is electromagnetic. Repulsion between electrons. The electrons in your hand and the electrons in the desk have the same charge. Like charges repel, so when you push down, you're feeling trillions of tiny electromagnetic interactions all adding up to what you call solid. Now here's the question that's going to really bother you. Why do like charges repel? You can't answer that, can you? You can. Say electromagnetic force, but that's just giving it a name. That's not explaining anything. It's like saying, why do magnets repel? Because of magnetic force. That's circular. That's not an explanation. The electromagnetic force is one of four fundamental forces in nature. It's not caused by something else. It's not derived from something simpler. It just is. And here's what nobody tells you. The force that stops your hand at the desk surface, that's the exact same force that makes magnets push apart. The same force, not similar, not analogous, identical, the electromagnetic force. So why does one feel obvious and the other feel mysterious? I'll tell you why. You've been pushing on solid objects since you were 6 months old. By the time you were 2, your brain had built up an enormous library of experiences. Pushing, grabbing, falling down, hitting the ground. Your neurons wired themselves around those experiences. They built patterns, expectations, a whole intuitive framework. So now, when you push on a desk, it feels normal, natural, obvious. You don't think about it. You don't think it needs explaining, but magnets push through empty space. You can see the gap. You can slide a piece of paper through. There's nothing there. That feels weird. That feels wrong. That feels like it needs an explanation. But here's the truth. The weirdness is in your head, not in the physics. When you push on the desk, the electrons in. Your hand never actually touch the electrons in the desk. They repel at a distance, a tiny distance, a few atomic widths, but still a distance. We call it contact because the distance is too small to see. But it's not really contact. Nothing is touching. It's electromagnetic repulsion operating across a gap. With magnets, the gap is bigger, a centimeter, an inch big, enough to see, big enough to make you uncomfortable. But the force is the same. The mechanism is the same. The only difference is scale. The mystery you feel is not a mystery in the physics. It's a mystery in your psychology. You're comfortable with electromagnetic repulsion at atomic distances because you've experienced it your whole life. You're uncomfortable with electromagnetic repulsion at centimeter distances because it's less familiar. That's it. That's the whole difference. Now, you're probably thinking, okay, fine, but surely quantum mechanics explains why the electromagnetic force exists. Wrong. Again, quantum electrodynamics, the quantum theory of electromagnetism, is the most precisely tested theory in all of science. We've measured certain predictions to 11 decimal places, and the theory matches exactly. But here's what QED does. It tells you how to calculate electromagnetic interactions with absurd precision. It gives you rules, equations, predictive power. What it does not do is tell you why the electromagnetic force exists in some deep philosophical sense. It describes the force beautifully, perfectly, but it doesn't explain it away. It doesn't reduce it to something simpler, because there isn't anything simpler. Let me show you how this works with a different example. You ask, why does ice float on water. I can tell you because. Ice is less dense than liquid water. Why is it less dense? Because the molecular structure has more space between them. Molecules, why does it have that structure? Because of how hydrogen bonds arrange themselves. At freezing temperatures, why do hydrogen bonds arrange that way? Because of the quantum mechanical properties of electrons in water. Molecules, why do electrons have those properties? Because of the Schrödinger equation and the Pauli exclusion principle. Why do those equations hold? See what's happening at each step? I'm giving you a deeper answer, but I'm also just pushing the question back one level. Eventually, and this happens, fast, you hit bedrock, the fundamental equations, the basic forces, and there, the only honest answer is that's what we measure. That's what the universe does. We can describe it mathematically. We can test it experimentally. We can use it to make predictions and build technology, but we can't explain it in terms of something more fundamental because there isn't anything more fundamental. The chain of why has to end somewhere. Here's the deep problem with your question about magnets. When you ask why, you're not really asking for information. You're asking for comfort. You're asking me to connect the unfamiliar thing to something familiar so you can stop feeling confused. You want a story, a narrative, a chain of cause and effect that ends with something you already understand. But magnets repel because of the electromagnetic force. And the electromagnetic force exists because that's a fundamental property of the universe. There's no story. There's no deeper because there's just measurement. And mathematics now, I know that's not satisfying. I know you want more. But the universe doesn't care what you want. The universe is what it is. Let me tell you what really bothers me about this question. You're treating magnets like they're special, like they're the one weird thing in a universe of normal things. That's backwards. Everything is. Electromagnetic, if you look closely. Enough. Why do chemicals react? Electromagnetic forces rearranging. Electrons. Why does light bounce off mirrors? Electromagnetic interaction. Why do you see colors? Electromagnetic radiation hitting your retina. Why does your computer work? Electromagnetic forces. Moving electrons through circuits. The electromagnetic force isn't some exotic phenomenon that only shows up in magnets. It's everywhere. It's the dominant force in your entire life. Gravity weaker by a factor of 10 to the 36, completely irrelevant for atoms and molecules. The strong and weak nuclear forces locked inside atomic nuclei, too, short range to affect anything you can touch. Everything else, and I mean everything, is electromagnetism. The force making magnets push apart is the same force holding your body together right now, the same force preventing you from falling through your chair, the same force letting you read these words. So when you ask me to explain magnetic repulsion by comparing it to something normal, you're asking me to explain electromagnetism. Using electromagnetism, it's circular. Can't be done. Let me try a different approach. Maybe this will help. You know how you can explain the color blue to someone who can see. You show them the sky, a blue shirt. You give examples, but how do you explain blue to someone blind from birth? You can talk about wavelengths about 450 nanometers. You can describe where it sits between red and green in the spectrum. You can give them all the physics of blue, but none of that conveys the experience, the actual bless. They have to see it. There's no shortcut. Same with magnets, same with electromagnetism. You don't get the intuition from an analogy. You don't get it from a 5-minute explanation. You have to work with the mathematics, solve problems, make calculations, predictions, test them. After months, maybe years of working with electromagnetic theory, something shifts in your brain. The equations start to feel natural, intuitive, obvious, not because they match your everyday experience, but because you've built a new everyday experience, mathematical experience with how fields behave. And then magnets aren't mysterious anymore. They're exactly what you'd expect inevitable consequences of charged particles and fields, but you can't shortcut that process. You can't skip to the end. You have to earn the intuition. Now, let me tell you what I can give you. The technical answer. Magnets have magnetic dipole moments, little arrows of magnetism. When you align lots of them in the same direction, you get a permanent magnet. Those dipoles create a magnetic field. Configuration that stores potential. Energy. Physical systems naturally evolve toward lower energy states. When two north poles face each other, the energy is high. Moving them apart lowers the energy, so they repel. That's the answer. That's as deep as it goes. You want to know why dipoles create fields? I can tell you about moving Charges and electrons spin. You want to know why electrons have spin? I can tell you about the Dirac equation in quantum mechanics. You want to know why the Dirac equation is correct? I can tell you it follows from combining special relativity with quantum mechanics. You want to know why those theories hold? Because they match reality, because we've tested them millions of times and they work. That's it. That's where the chain ends. Here's what you need to understand about how physics actually works. We don't start with philosophy and derive the universe. We start with measurements. We observe patterns. We write equations that describe those patterns. We test those equations against new experiments when the equations work, when they let us predict things we haven't seen yet. We say we understand the phenomenon. Understanding in physics doesn't mean philosophical satisfaction. It doesn't mean matching your intuition. It means predictive power. It means being able to calculate, to predict, to build. Technology that works by that standard we understand. Electromagnetism better than almost anything. Quantum electrodynamics is tested to incredible precision. We can calculate the magnetic moment of an electron to 11 decimal places in the measurement. Agrees exactly. So when I say I understand magnets, I mean this. I can calculate the force between them. I can predict how they'll behave in different configurations. I can design electric motors, generators, MRI machines. I can manipulate magnetic fields to trap particles or focus beams. That's real understanding. That's what physics offers. Not comfort, not familiar analogies, but power, control over nature. You might not like this answer. You might find it unsatisfying, tough. The universe doesn't owe you an explanation that makes you comfortable. It doesn't owe you a story that matches your intuition about how things should work. Your intuition evolved to throw rocks, pick fruit, and avoid predators. On the African savanna, it did not. Evolved to understand quantum fields or electromagnetic interactions at the atomic scale. So when physics reveals something that violates your intuition, particles acting like waves, time slowing down at high speeds, magnets pushing through empty space, you have two choices. You can reject it as mysterious and unsatisfying and keep asking for better explanations that don't exist, or you can expand your intuition, learn the mathematics, work through the problems, build new mental models based on equations and experiments, not everyday experience. That's what physicists do. None of us found quantum mechanics intuitive at first, but we worked with it long enough that it became familiar, and eventually it started to feel natural, not because it matches common sense, but because we built new common sense, mathematical common sense. So here's what I want you to take away from this. The next time you pick up two magnets and feel them push apart, don't. Ask why. Ask how. How does the force depend on distance? How strong is it compared to gravity? How can I calculate it? How can I use it? Those questions have answers. Good. Answers, precise answers, beautiful. Answers, the why question, the one asking for. Reduction to something more familiar. That question doesn't have an answer. Not for magnets, not for any fundamental. Force. Because fundamental means exactly that bottom level, nothing underneath. But here's the beautiful thing that people miss when they get stuck on why what physics reveals is that the universe operates according to a small set of rules. The same equations that describe magnets also describe lightning, brain signals, computer, chips, the northern lights, chemical, bonds, why stars shine, why atoms are stable. That's not a failure to explain. That's unification. That's discovering that underneath all. The apparent complexity and chaos of nature. There's a deep structure, a mathematical structure, simple rules with incredibly complex consequences. That's what should blow your mind. Not that we can't reduce magnets to something simpler, but that we can reduce thousands of seemingly different phenomena to the same underlying force. You wanted me to explain magnets by comparing them to something familiar, but I'm telling you something better. Everything familiar is actually magnets, or rather everything is. Electromagnetism, same thing. Your desk, your body, the air, light, chemistry, life itself, it's all different aura. Dimension. Electromagnetic interactions, you're not separate from the magnets, you're made of the same force. So was my refusal to answer the BBC interviewer arrogant? No, it was honest. I could have given him a comfortable lie. Magnets are like springs, or think of magnetic fields as rubber sheets, or whatever would have made him nod and feel satisfied, and he would have learned nothing. Instead, I told him the truth. The question itself was broken. The kind of why he wanted doesn't exist. At the fundamental level, things just are. And our job is to describe them accurately, not to reduce them to something more comfortable. People hated that answer, called it evasive, called it a failure to communicate. But they were wrong. Sometimes the most honest answer is the universe doesn't work the way you expect. Your intuitions are wrong. And if you want to understand what's really happening, you need to learn a new way of thinking. That's not arrogance, that's respect. Respect for the truth, respect for the actual structure of reality, and respect for you, for your ability to handle that truth instead of needing a comfortable fiction. So pick up those magnets one more time, feel that invisible push. Now, understand you're feeling one of the four fundamental forces of nature. The same force that makes chemistry work, the same force that makes stars shine, the same force holding you together. Right now. That's not mysterious. Why does fire burn? Sounds like a child's question. And that's exactly why most adults answer it badly. You'll hear things like, because it's hot, because of heat energy, because of combustion. Congratulations, you've learned new words, not new understanding. Let's slow down. Fire doesn't decide to burn you. Fire doesn't know you exist. Fire is not angry. Fire is not violent. Fire is just atoms doing what atoms do. So what's really happening? When something burns, atoms rearrange themselves, electrons shift positions, chemical bonds break and form again. That rearrangement releases energy. Now here's the part people skip because it's uncomfortable. Heat is not a thing, it's a description of motion, atoms vibrating, molecules slamming into each other, pure microscopic chaos. When that chaos reaches your skin, the molecules in your body are forced to vibrate faster than they're supposed to. Your nerves detect this disruption and scream one word: danger. Pain is not fire attacking you. Pain is your body saying, this process will destroy our structure if it continues. Fire doesn't burn you. Energy transfer does, and here's where reality starts to crack. If you keep asking why deeper and deeper, explanations start turning into interactions. Not what things are, but what they do to each other. At some level, there is no final answer. Only better questions. Why does energy transfer cause pain? Why do atoms behave this way? Why does the universe allow stable structures at all? You can't point to a single sentence and say, that's it, that's the truth. Reality isn't built from answers, it's built from relationships. Fire burns because matter follows rules. Your skin reacts because biology evolved alarms. Your mind wants a simple answer because uncertainty is uncomfortable. And that's the real danger. Not fire, false certainty. The moment you stop questioning simple things, you stop understanding complex ones. So the next time you see fire, don't ask, why does it burn? Ask something better. What is really happening? And how far am I willing to follow the question? That's where thinking begins. The question is not simple. Your brain just pretends it is. The moment you hear, why does fire burn? Your mind rushes to close the case. It wants the discomfort gone as fast as possible. It grabs the nearest word that sounds scientific, wraps it like a badge of authority, and declares victory. Heat, energy, combustion, done. Question answered, move on. But nothing was answered. You just sedated your curiosity. Your brain is lazy in a very specific way. It hates open loops. An unanswered question feels like an error message running in the background. So the brain learns a survival trick. Replace understanding with labels. A word feels like knowledge. A definition feels like closure. And most people never notice the difference. When a child asks why fire burns, they're actually asking something terrifying. What is reality made of, and why does it hurt me? That's not a small question. That's a crack in the surface of the world. Adults panic when cracks appear, so they plaster them over with vocabulary and call it education. Here's the uncomfortable truth. Most explanations are just stories we tell ourselves to stop thinking. Fire burns because it's hot. That's not an explanation. That's a loop. Why is it hot? Because it releases heat. What is heat? Energy. What is energy? Now watch what happens. The confidence drops. The voice slows down. The certainty evaporates. Suddenly the room gets quiet because the words stop pointing to things you can imagine. This is where real thinking begins. And this is exactly where most people turn back. Your brain pretends the question is simple, because complexity threatens its sense of control. If the world is simple, you're safe. If it's not, then you're standing on top of interactions you don't fully understand, governed by rules you didn't design, inside a universe that doesn't care about your intuition. So instead of asking, what is really happening, we ask, what's the shortest answer that sounds respectable? Fire feels basic because you've seen it your whole life. Candles, stoves, matches. Familiarity creates the illusion of understanding. But familiarity is not depth. You can use something daily and still be completely ignorant of its nature. Fire is not a thing you can point to. It's not an object, it's not a substance, it's a process, a rapid rearrangement of matter at the atomic level. But even that sentence is dangerous because it sounds like an answer when it's actually just another doorway. Atoms rearranging, according to what rules? Electrons moving, why those movements? Energy released? What does released even mean? You see the problem now. Every time you ask why, the floor drops another level. Your brain wants a bottom, a final sentence, a bedrock explanation where you can stop digging and rest. But reality doesn't offer that comfort. Reality offers layers, not conclusions, and this is why the question isn't simple. When fire touches your skin, nothing mystical happens. No essence of burning leaps into you. What happens is brutally mechanical. Molecules in the flame collide with molecules in your body. Energy transfers, bonds strain, structures destabilize. Your nervous system interprets this disruption as a threat to integrity and sends a signal you call pain. Pain isn't fire being cruel. Pain is information. It's your body saying this interaction is incompatible with survival. Even that explanation isn't final. It just pushes the question deeper. Why do nerves work that way? Why does biological matter have thresholds? Why does the universe allow stable patterns at all? At some point, explanations stop being answers and start being maps, and maps are not territory. The brain pretends the question is simple because it confuses maps for reality. It mistakes the description for the thing. It hears a confident sentence and relaxes, unaware that confidence is not accuracy. This is why people argue endlessly about explanations without ever touching understanding. They defend words. They memorize frameworks. They repeat phrases. But they never test whether those phrases actually explain anything. A real explanation reduces mystery without killing curiosity. A fake one kills curiosity instantly. Fire burning you is not a fact you know. It's an event you experience and barely understand. The moment you feel pain, your body reacts faster than your thoughts. And then, afterward, your brain rushes in to narrate the event in a way that makes the world feel manageable again. That narration is useful, but it is not truth. The danger is not ignorance. The danger is thinking you understand when you don't. Once you accept shallow answers, you train your mind to stop asking dangerous questions. And once that habit forms, everything becomes simple. Politics, science, morality, even reality itself. Simple, clean, wrong. So when you hear why does fire burn, and your brain jumps to an answer in under a second, don't trust it. That speed is not intelligence. It's avoidance. Slow down. Follow the question. Let it destabilize you, because the moment a question feels simple, it's almost guaranteed that you stop thinking too early. Words are not explanations. They are placeholders your brain uses when it doesn't want to keep digging. The moment a word enters the conversation, most minds relax. The tension disappears. The question feels handled, but nothing actually changed in the world. You didn't uncover a mechanism. You didn't see a process unfold. You just replaced confusion with a sound that feels authoritative. This is how ignorance hides in plain sight. Say the word energy and watch what happens. Heads nod, eyebrows relax. The discussion moves on. But ask a simple follow-up. What exactly do, you mean by energy in this situation? And suddenly the word collapses. It stretches to cover everything and explains nothing. Words are tools, not truths. They point, they gesture, they label patterns so we can talk about them. But labels are not causes. Naming a thing does not explain how it works or why it behaves the way it does. Calling fire hot doesn't explain burning. Calling burning combustion doesn't explain pain. Calling pain a nerve response doesn't explain why that response exists or why it feels the way it does. Each word simply pushes the mystery one layer deeper, while giving the illusion that progress was made. This illusion is powerful because language evolved for coordination, not understanding. Words help groups act together. They help us warn, command, teach, and survive. They were never designed to reveal the fundamental structure of reality. Yet we treat them as if they were microscopes. This is why people argue endlessly using the same vocabulary and never get closer to truth. They're fighting over symbols, not mechanisms. One person swaps one word for another and thinks they've changed the explanation. They haven't. They've just rearranged the furniture. The mind loves this because words feel like control. When something has a name, it feels contained. It feels manageable. Unnamed things feel dangerous. So the brain grabs words like anchors and calls the ocean shallow. But reality doesn't care what you call it. When you say fire burns because of energy transfer, you haven't explained burning. You've just described the event using a framework that already assumes understanding. It's like explaining a magic trick by saying the magician used a technique. True, but useless. A real explanation forces you to confront interaction. It shows how one thing pushes on another. It exposes constraints, limits, and consequences. Words alone don't do that. They only summarize after the fact. This is why education often fails at the exact moment it sounds the most confident. Students memorize definitions and mistake fluency for insight. They can repeat sentences flawlessly and still have no mental picture of what is happening. The words sit in their heads like decorations, not tools, and the tragedy is that once words feel sufficient, curiosity dies. Questions stop. The mind moves on, satisfied with a counterfeit understanding, but nature is not built from definitions. It's built from behavior. Atoms don't care what you call them. Forces don't respond to terminology. Pain doesn't disappear because you described it accurately. The universe runs on relationships and rules, not vocabulary. The deeper you go, the more fragile words become. At some point, language starts to fail entirely. Concepts stretch beyond intuition. Mathematics replaces adjectives. Diagrams replace sentences. Even then, those are still representations, not the thing itself, and this is the humbling part most people avoid. There may not be a final verbal explanation at all. You can describe processes more precisely. You can model them, predict them, use them, but turning reality into a neat paragraph that makes sense may be impossible. The demand for that kind of explanation is a human craving, not a requirement of the universe. Words are useful, necessary even, but the moment you confuse them for explanations, you stop learning. Real understanding begins when you treat words as questions, not answers. When every term you use becomes an invitation to ask, what is actually happening here? When definitions no longer end thought but start it. So the next time someone explains something with a confident sentence full of impressive vocabulary, don't be impressed. Ask what the words are hiding. Ask what interactions they're standing in for. Ask what would remain if the labels were stripped away. Because reality doesn't speak in words. We do. And the moment we forget that difference, we trade understanding for comfort. And CA. LLT, knowledge draw reality is interaction, not objects. And the moment you stop clinging to things and start watching what they do to each other, the world changes shape. We grow up thinking reality is made of solid pieces, tables, fire, skin, air, separate things occupying space, bumping into one another like billiard balls. It feels obvious. It feels intuitive. And it's almost entirely wrong. Objects are a mental shortcut. They're how the brain compresses experience so it can function. But what actually exists underneath that shortcut is not static stuff. It's behavior, motion, exchange, relationship, take fire. You think of it as a thing you can point to, but try to grab it. There's nothing to hold, no substance you can isolate and keep. Fire exists only while something is happening. Stop the interaction, remove oxygen, fuel, or heat, and the object vanishes, not moves away, vanishes. That alone should make you suspicious of object-based thinking. At the deepest level, there are no hard boundaries. The surface of your skin feels like a clear line between you and the world, but it's not. Molecules from the air pass through you with every breath. Heat flows in and out constantly. Even the atoms in your body are not permanent residents. They're replaced over time, traded with the environment, swapped like parts in a machine that never turns off. So where exactly do you end? The idea of an object suggests permanence and independence, but nothing is independent. Everything is defined by what it interacts with. An electron is not an electron in isolation. Its properties only make sense in relation to other charges, fields, and forces. Remove the interaction, and the concept collapses. Burning is not fire attacking you. It's not an object acting on another object. It's a cascade of interactions, fast-moving molecules colliding with slower ones, energy redistributing itself, bonds stretching past their limits. The pain you feel is not caused by fire as a thing, but by a process overwhelming your body's ability to maintain its structure. This shift in perspective is uncomfortable because it dissolves the furniture of reality. Things stop being solid and start becoming events. And events don't sit still. They don't wait for your intuition to catch up. We prefer objects because they're easy to blame, easy to name, easy to control in our imagination. If fire is a thing, then it's the culprit. If it's interaction, then responsibility dissolves into a web of conditions. Oxygen, fuel, temperature, timing. Remove any one, and the outcome changes. That's not how we like to think, but that's how reality operates. Even your body is not a thing. It's a negotiated truce between forces trying to pull it apart and processes holding it together. Life itself is not an object you possess. It's a pattern you maintain, temporarily. This is why deep explanations rarely point to what something is. They point to what it does, how it behaves, and under what conditions it changes. Science doesn't progress by cataloging objects. It progresses by uncovering relationships. When you stop thinking in objects, causality becomes clearer. Fire doesn't burn paper because fire is destructive. Paper burns because its molecular structure allows certain reactions when exposed to specific interactions. Change the structure, change the outcome. No drama, no intention, just rules playing out. This perspective also kills a comforting illusion that the world is made for human understanding. It's not. Objects feel natural to us because our brains evolved to survive at a certain scale. At that scale, object thinking works well enough. At deeper levels, it fails completely. Reality doesn't care how you slice it into nouns. It runs on verbs. Interactions are messy, layered, and often counterintuitive. They don't offer clean explanations you can memorize. They require you to think in systems, not things. Processes, not possessions. Relationships, not LA. Bells. Once you see this, questions change. You stop asking, what is it? And start asking, what happens if? You stop demanding essence and start tracking behavior. You stop looking for villains and start examining conditions. Fire stops being mysterious and starts being precise, not simpler, more honest. Objects are how we talk. Interactions are how the universe works. And the closer you get to that truth, the harder it becomes to pretend that reality is made of neat, separate things waiting to be named. Pain is information, not punishment. And the moment you stop treating it like an enemy and start reading it like a message, it loses its mystery and gains its meaning. We grow up thinking pain is something that happens to us, as if the universe decided to hurt us, as if pain were a moral judgment, a consequence, a punishment for touching the wrong thing. That instinct is deeply human, but it's also deeply wrong. Pain is not justice. Pain is not anger. Pain is not cruelty. Pain is data. When fire touches your skin, nothing personal occurs. The universe does not react to your mistake. There is no intention behind the sensation. What happens is far more mechanical and far less dramatic. Structures in your body are being pushed beyond the limits that keep them intact, and your nervous system detects that boundary being crossed. That detection is pain. Pain exists because survival requires prediction. A system that waits until damage is complete is a dead system. So biology evolved an early warning signal, one that screams before destruction finishes its work. Pain is not damage itself. It's the forecast. This is why pain can exist without visible injury, and injury can exist without pain. The signal is not the event. It's an interpretation. Your nerves don't report truth. They report urgency. They measure changes, pressure, temperature, chemical imbalance, and translate those changes into a single demand: act now. Pain simplifies complexity into something the organism cannot ignore. It hijacks attention because attention is life. Fire doesn't hurt you, energy transfer does, and even that statement is only useful if you go deeper. The energy doesn't want to hurt you, it spreads because spreading is what energy does. Your tissues resist because their structure requires stability. Pain emerges at the boundary where those two facts collide. This reframes something important. Pain is not an enemy to be defeated. It's a language to be understood. We treat pain like a moral signal, good versus bad, when it's actually a directional one. It doesn't say you are wrong. It says this path leads to disintegration. Ignore it and the structure fails. Respect it and the system adapts. This is why pain feels so absolute. It has to override hesitation. There is no room for debate when the hand is in the fire. Evolution didn't design pain to be philosophically interesting. It designed it to be effective. But effectiveness comes with a cost. Pain is blunt. It lacks nuance. It cannot explain itself. It only points and shouts. So humans invent stories around it. We moralize it. We dramatize it. We turn it into punishment because punishment fits our social instincts. But the universe is not running a courtroom. Pain doesn't care if you're brave, foolish, innocent, or experienced. It activates under conditions, not character. This is why understanding pain changes how you see reality. It strips away the idea that the world reacts emotionally to your actions. There is no reward system built into physics. There are only consequences. Touch fire, energy flows. Flow exceeds tolerance. Signal triggers, no meaning, no lesson, just mechanics. Yet those mechanics are enough to shape behavior, culture, and entire civilizations. Pain is one of the most powerful teaching tools in existence, not because it explains, but because it forces attention. And here's the uncomfortable insight. Pain is not there to make sense. It's there to keep you intact long enough to ask better questions later. Once you understand pain is information, not punishment, fear loses some of its grip. You stop asking, why is this happening to me? And start asking, what condition triggered this signal? That shift is everything. It turns suffering into feedback. It turns injury into instruction. It turns reality from a judge into a system. Fire didn't hurt you to teach you a lesson. Your body warned you so it could continue existing. Pain is not cruelty, it is communication. Written in urgency, delivered without explanation, and designed to be impossible to ignore. The tragedy is not pain itself. The tragedy is misunderstanding it. Because when you mistake information for punishment, you stop listening. And when you stop listening, reality doesn't become kinder. It just becomes quieter right before things break. Understanding ends where curiosity dies, not because the world runs out of answers, but because the mind decides it has had enough discomfort. Curiosity is not a personality trait. It's a behavior under pressure. It appears when certainty fails and disappears the moment comfort returns. The instant an explanation feels good enough, curiosity shuts down, and with it the possibility of deeper understanding. This is how ignorance stabilizes itself. The brain doesn't stop asking questions because it has reached truth. It stops because continuing would cost energy, confidence, or social approval. Asking why too long makes you look difficult. It makes conversations awkward. It exposes how little you and everyone else actually knows. So most people learn when to stop. They learn which answers are socially acceptable endpoints. They learn which questions make others uneasy. They learn to trade curiosity for belonging, and they call that maturity. But understanding doesn't work that way. Understanding is not accumulation, it's endurance. It's how long you can stay inside uncertainty without escaping into slogans, definitions, or authority. The moment you outsource curiosity to someone else, a book, an expert, a tradition, your own understanding freezes at that level. This is why education often produces confidence without clarity. Students learn where the question marks are supposed to end. They memorize the stopping points. But reality doesn't respect curriculum boundaries. Fire doesn't care that you learned its definition. Pain doesn't care that you can explain it. Nature does not pause because your curiosity got tired. When curiosity dies, explanations harden into dogma. What was once a model becomes a belief. What was once a tool becomes an identity. And once understanding becomes part of who you are, questioning it feels like self-destruction, so the mind protects itself by closing doors. The real danger is not being wrong. It's losing the ability to notice that you might be curiosity is uncomfortable because it destabilizes. Every real question threatens to unravel something you rely on. Your competence, your worldview, your sense of control. That's why curiosity is often mistaken for doubt, and doubt for weakness. In reality, curiosity is the only thing strong enough to survive contact with complexity. When you stop being curious, the world becomes simple. Not because it is, but because you flattened it. You replace living systems with static explanations. You stop seeing processes and start seeing labels. You trade inquiry for certainty and call it wisdom. But certainty is not understanding. It's a decision to stop looking. Fire burning, pain signaling, energy transferring. These are not facts you finish learning. They are starting points. Each one opens into deeper layers of interaction, constraint, and relationship. There is always another why, not because knowledge is infinite, but because explanation is contextual. Every answer only makes sense relative to the questions you allow yourself to ask. When curiosity dies, understanding doesn't just stop growing, it decays. Old explanations become brittle. They stop adapting to new information. They fail under pressure. And when reality finally contradicts them, the response is not learning, but denial. This is how people end up defending explanations that no longer explain anything. They protect the answers because they abandon the process that created them. Curiosity is not about chasing novelty. It's about refusing premature closure. It's the discipline of not mistaking comfort for truth. The universe does not reward certainty. It rewards alignment with how things actually behave. Curiosity is the mechanism that keeps adjusting that alignment. The moment you say, that's just how it is, you're no longer understanding, you're surrendering. Understanding doesn't end because there is nothing left to know. It ends because asking became more threatening than not knowing. So if you want to know where understanding truly stops, don't look for the hardest question. Look for the moment you stopped asking one. You think the speed of light is just a number? 299792458 ms. Fast, really fast. The fastest thing we know, fine. But why is it the limit? Why? Can't you go faster? What stops you? Most people have never really thought about this. They just accept it. Einstein said so. Speed of light is the cosmic speed limit. That's just how it is. But that's not an answer. That's just repeating words. When you really ask why nothing can go faster than light, when you dig into what's actually stopping you, you discover something so strange, so fundamentally different from everyday experience that it changes everything you think you know about space and time. The speed of light isn't just a speed. It's not just the fastest thing. It's the structure of the universe itself. It's woven into the fabric of space and time in a way that makes going faster literally meaningless. Let me show you what I mean. Let's start with something simple, something everyone knows. Things fall, drop something, it falls down. 16 ft in, the first second to be precise. That's what Galileo measured. Drop a ball, drop a rock, drop anything in 1 second. It falls 16 fort, now the moon. The moon is going around the earth. It's not falling down. It's staying up there orbiting, going in a circle. But wait, is it falling? Think about it. If the moon were just sitting there in space, not moving, what would happen? It would fall toward the earth. Gravity would pull it in, but the moon is moving. It's moving sideways, tangent to its orbit. And because it's moving sideways while gravity pulls it down, it keeps missing the earth. It falls toward the earth, but keeps missing. That's what an orbit is, continuous falling while moving sideways, fast enough to keep missing. Now, here's where Newton had his brilliant insight. The moon is 240,000 mi from the center of the earth. We're standing on the surface 4,000 mi from the center. So the moon is 60 times farther away than we are. Newton said, what if gravity gets weaker with distance? What if it follows an inverse square law? That means if you go twice as far away, gravity becomes 4 times weaker, 3 times as far, n times weaker the square of the distance. If that's true, then at the moon's distance 60 times farther, gravity should be 62 times weaker. That's 3,600 times weaker. Now, on Earth, things fall 16 ft in 1 second. If gravity at the moon is 3,600 times weaker, then the moon should fall toward Earth by 16 feet, 3,600. Do the math. 16 fort divided by 3,600. That's about 1/12 of an inch per second squared. Wait, let me say that differently. In 1 second, something at the moon's distance should fall toward Earth by 1/12 of an inch, 3,600, because we're talking about the square of time in the formula. 1/12 of an inch, 3,600 equals 16 fort, exactly what we measure on Earth. Newton calculated how far the moon should fall toward Earth in 1 second if gravity follows an inverse square law, and it matched perfectly. The moon is falling at exactly the rate Newton's law predicts. This was huge. This wasn't just a theory. This was a prediction. Newton took a completely independent fact, how fast things fall on Earth, and connected it to another completely independent fact, the period of the moon's orbit and its distance from Earth. Two things that seemed totally unrelated suddenly became connected by one law, the law of gravitation. There was no going back. Now, Newton went further. He calculated what the shape of planetary orbit should be if gravity follows an inverse square law, and he found that it should be an ellipse. And guess what? Planets do move in ellipses. Kepler had already measured that, but Kepler didn't know why. Newton explained it. He got 3 for 2, as it were, and then more things fell into place. The tides. Why are there tides? Because the moon pulls on the Earth. But wait, if the moon just pulls the Earth toward it, there should only be one high tide per day, right? The bulge of water on the side facing the moon. But there are 2 tides per day every 12 hours, roughly. Why? Some people thought the Earth was pulled away from the water. Others thought the water was pulled toward the moon. Both were sort of. Right, but neither got it completely. Newton realized what was really going on. The force of the moon on the Earth and on the water is the same at the same distance. But the water on the near side is closer to the moon than the Earth is, so it gets pulled more. And the water on the far side is farther from the moon than the Earth is, so it gets pulled less. So you get 2 bulges, one where the water is pulled more toward the moon, one where the water is left behind, because the Earth is pulled more than that water. 2 tides per day. Actually, the Earth does the same trick as the moon. It goes around a circle. The center of the circle is somewhere inside the Earth. The Earth and moon both orbit their common center of mass. If you wish, this water is thrown off by a centrifugal force more than the Earth is. And this water is attracted more than the average of the Earth. At any rate, the tides were explained, and the fact that there were 2 a day, a lot of. Other things became quite clear. Why the Earth is round? Because everything gets pulled in. Why it isn't perfectly round? Because it's spinning. So the outside gets thrown out a little bit and it balances. Why the sun and moon are round, and so on. Now, as science developed and measurements were made ever more accurately, the tests of Newton's law became much more stringent. The first. Careful tests involved the moons of Jupiter. By careful observations of the way they went around over a long period of time, one could check very carefully that everything was according to Newton's laws, and it turned out not to be the case. The moons of Jupiter appeared to get sometimes 8 minutes ahead of schedule and sometimes 8 minutes behind the schedule, where schedule is the calculated values according to Newton's laws. 8 minutes, that's a huge discrepancy. Something was wrong. But wait, it was noticed that they were ahead of schedule when Jupiter was close to the Earth and behind schedule when Jupiter was far away. Rather odd circumstance. Mr. Roma, having confidence in the law of gravitation, came to an interesting conclusion. It takes light some time to travel from the moons to the Earth. And what we're looking at when we see the moons are not how they are now, but how they were some time ago. The time it took the light to get here. When Jupiter is near us, it takes less time for the light to come. When Jupiter is farther, it takes longer. So he had to correct the observations for the differences in time, and by the fact that they were this much too early or that much too late, he was able to determine the velocity of light. This was the first demonstration. That light was not instantaneously propagated. Think about what just happened. We found the speed of light, not by measuring light directly, but by having confidence in the law of gravitation when something didn't match, instead of throwing out Newton's law. Roma said, what if light takes time to travel? And he was right. I bring this particular matter to your attention because it illustrates something. When a law is right, it can be used to find another one by having confidence in this law. If something is the matter, it suggests perhaps some other phenomenon. And if we had not known the law of gravitation, we would have taken much longer to find the speed of light, because we would not have known what to expect of Jupiter's satellites. This process has developed into an avalanche of discoveries. Each new discovery permits the tools for much more discovery. And this beginning, it's the beginning of that avalanche which has gone on now for 400 years in a continuous process. And we're still avalanching along at high speed at this time. But here's the thing. Once you know the speed of light, once you measure it, you start noticing something very, very strange. Light always travels at the same speed. Always. No matter who measures it, no matter how fast you're moving. Let me make this concrete. You're standing still. You shine a flashlight. You measure the speed of the light coming out. 299.792.458 M's fine. Now you get on a train, a fast train moving at, say, half the speed of light. You shine the flashlight forward. In the direction the train is moving, common sense says the light should now be traveling at the speed of light plus the speed of the train. Just like if you throw a ball forward from a moving train, the ball moves faster than if you threw it while standing still. But that's not what happens. You measure the light, it's still traveling at 299.792.458 ms, exactly the same speed. You say, okay, maybe I measured wrong. So you get the train going even faster, 90 the speed of light. You shine the flashlight forward again, you measure still 299.792.458 ms. You get frustrated. You get the train going at 99.9999 the speed of light. You shine the flashlight, you measure, still the same speed. The speed of light does not add, it doesn't combine with your speed. It's always the same, no matter how fast you're moving. This should break your brain. This is not how speeds work in every day life. Speeds add. If you're on a train moving at 50 miles per hour and you walk forward at 3 miles per hour, moving at 53 miles per relative to the ground. But light doesn't do this. Light always moves at the same speed relative to you, no matter how fast you are moving. Why? Einstein realized what was going on, and it's so strange, so contrary to common sense that even now, over a century later, people struggle to accept it. Time and space are not fixed. They're flexible. They bend and stretch to keep the speed of light constant. When you move faster, time slows down. For you, Your clock literally ticks. Slower and distances contract. The space in front of you gets compressed. These effects are real. They are not. Optical illusions. They're not. Measurement errors. Time actually slows. Space actually contracts. And the amount they change is exactly the right amount to make the speed of light come out the same for everyone. Let me say that again. The universe adjusts time and space, bends them, stretches them, compresses them to ensure that light always travels at the same speed for everyone. The speed of light is not just a speed, it's a structural constant of the universe. Space and time are arranged in such a way that this speed is the same for everyone. Now, here's where it gets even stranger. If you try to accelerate something, anything to the speed of light, something very weird happens. The closer you get to the speed of light, the harder it becomes to go faster. It's not that you run out of fuel. It's not that your engine isn't strong enough. It's that the object itself resists acceleration more and more. We call this relativistic mass increase. As you go faster, your inertia increases. It becomes harder and harder to push you faster. And as you approach the speed of light, your inertia approaches infinity. To actually reach the speed of light, you would need infinite energy, which is impossible. So nothing with mass can ever reach the speed of light, not because of some arbitrary rule, not because of engineering limitations, but because the structure of space-time itself prevents. Light can travel at that speed because photons have no mass. Zero massless particles can travel at the speed of light. In fact, they must. They have no choice. They're always moving at that speed. But anything with mass, it can get close, very close. 99.99999 of the speed of light, but never quite there. Universe won't let you. Now, you might ask, but why? Why is the universe set up this way? Why is there a speed limit at all? And here's the answer that's going to frustrate you. There isn't a deeper why. The speed of light isn't the speed limit imposed on the universe. It's a consequence of how the universe is. Structured space and time are not separate. They're woven together into space-time, and space-time has a geometry, a structure, and that structure has a built-in conversion factor between space and time. That conversion factor is the speed of light. It's not that light is special. It's that space-time has a maximum rate at which cause and effect can propagate. Light happens to travel at that rate because light has no mass, but the rate itself is a property of space-time, not of light. If light didn't exist, the speed limit would still be there. It's a feature of the universe itself. Here's another way to think about it. In everyday life, you think of space and time as separate things. You move through space. Time passes. They're independent, but they're not. You're always moving through space-time at a constant rate. Always, but that motion is divided between space and time. If you're sitting still, all your motion is through time. You're moving into the future at maximum speed, 1 second per second. But if you start moving through space, you have to divert some of that motion away from time. You're now moving through space and time, which means you're moving through time more slowly. The faster you move through space, the slower you move through time. And there's a maximum. If you could move through space at the speed of light, you would have zero motion left for time. Time would stop for you. This is why light doesn't experience time. From a photon's perspective, it's emitted and absorbed in the same instant. No time passes. The universe is frozen. You can't go faster than light because you can't have less than zero motion through time. That's the limit. That's the wall. And here's the beautiful part. This isn't just theoretical. We've tested this over and over and over. Particles and accelerators get accelerated to 99.99999, the speed of light. And guess what? The closer they get, the harder it becomes to accelerate them further, exactly as predicted. GPS satellites have to account for time dilation. They are moving fast and they're in a weaker gravitational field, so time passes differently for them than for us on the ground. If we didn't correct for this, GPS would be off by miles within a day, muons created in the upper atmosphere by. Cosmic rays should decay before reaching the ground. Their lifetime is too short, but they're moving close to the speed of light, so time slows down for them. From their perspective, they live long enough to reach the ground. From our perspective, they live longer because they're moving fast. Either way, more Muons reach the ground, then should. Exactly as relativity predicts, it's not speculation. It's measured, the speed of light being a limit is as well tested as anything in physics. So let's bring this all together. Why is the speed of light the limit? Because space-time is structured in a way that has a maximum rate of cause and effect. That rate is the speed of light. Not because light is special, but because space-time itself has this built-in conversion factor between space and time. You can't go faster because going faster would require moving backwards in time, which doesn't make sense. You can't have negative time. You can't undo cause and effect. The speed of light is the speed at which now propagates through the universe. It's the speed at which information can travel. It's the speed at which forces act. It's the maximum rate of change. And this process, this avalanche of discovery, started with Newton figuring out gravity by watching the moon. Then Roma figuring out the SPE, ed of light, by watching Jupiter's moons. Then Einstein realizing that the speed of light is constant and deriving relativity from that. Then thousands of experiments confirming it. Each discovery building on the last, each new insight opening doors to more insights. That's how science works. That's the avalanche that's been going on for 400 years. And we're still avalanching along at high speed at this time. The speed of light isn't just a number. It's the key. It's the thing that unlocks how space and time work. It's